Hello everybody, this is me Vinu Venkatesh on behalf of Sai Education for Comparative Examinations. So today we're going to continue with the chapter on surds and indices. We have discussed what surds are. Surds are nothing but irrational roots of integers, that is, roots of numbers which are not perfect squares or perfect cubes, as we have seen. We've also looked at some of the rules in how to add, subtract, multiply and divide surds, right? Now let's look at what indices are. So what is an index? Index is the power of exponent which is raised to a number or a variable. So for example, 2 raised to 4. 4 is the index of 2. It is nothing but the exponent. It is also called exponent. The plural form of index is indices. Okay. So you know what exponents are. It's the same as index. Now, if you look at number 21, it's very simple. You know, we have gone through this in our previous exercises. So 3 raised to 4 into 3 raised to 5. How do you solve this? Do you expand 3 raised to 4 and 3 raised to 5 and then multiply? It's going to take a lot of time. So the rule is, when the bases are same, what is a base? Base is this number 3. In this case 2 is the base. In this case 2 is the base. 4 is called the index or the exponent. So when we are multiplying two terms where the bases are the same, then we can add the exponents. So it will be, so a raised to m into a raised to n can be written as a raised to m plus n. So here it will be 3 raised to 4 plus 5, which is 3 raised to 9. Then only you will have to expand it, or you can leave it like that. But you can add it only when the bases are the same. So this is rule number 1. Okay, for the second rule, let's look at number 26. Okay, when two terms, that is exponential terms, these are called exponential terms, they are divided, where the bases are the same, but it is division instead of multiplication. For example, 8 cube divided by 8 square. Then, because the bases are the same, we can subtract the exponents. It will be, since the bases are the same, we can solve it by using this rule. A raised to m divided by a raised to n is equal to a raised to m minus n. In this case, it will be 8 raised to 3 minus 2, which is 8 raised to 1, which is 8. This is a simpler way of solving it, just like this. But here for multiplication, we must add. For division, when the bases are the same, we should subtract the exponents. So for multiplication, when the bases are the same, we should add the exponents, right? Okay. Next, number 22. 3 square, whole thing raised to 3. That is 3 square brackets raised to 3. In such cases, we multiply the exponents or the indices. That is, a raised to m brackets raised to n is equal to a raised to m into n. So this will be 3 raised to 2 into 3, which is 3 raised to 6, which is 729. This is an easier way of doing it. You can do it directly, but that is a long way. This is a shortcut method, and this is a rule which you have to follow. So this is rule number 3. Rule number 4. Rule number 4. 4 into 2, the whole thing raised to 5 can be written as 4 raised to 5 into 2 raised to 5. So when you have brackets and an exponent outside the brackets, you can take the exponent to each of the individual terms when there is a multiplication sign. Okay. If there is addition, you can't do it. So ab raised to m is equal to a raised to m into b raised to m. So in this case, it will be 4 raised to 5 into 2 raised to 5, which is equal to 8 raised to 5. Or you can simplify it like this. 4 raised to 5, find the answer, into 2 raised to 5, find the answer, right? Okay, number 24. Any number raised to 1 is the number itself. So a raised to 1 is a. Therefore, 10 raised to 1 is 10. Okay, any number raised to 1 is the number itself. Any number raised to 0 is equal to 1. For example, 10 raised to 0 is equal to 1. A raised to 0 is equal to 1. 1 lakh raised to 0 is equal to 1. Okay. Next, for number 25, let me tell you this. If a raised to m is equal to a raised to n, then this means that m is equal to n. For example, if 5 raised to m is equal to 5 raised to z, then this means that m is equal to z. Okay, because in an algebraic equation, if a raised to m is equal to a raised to n, then this means that the exponents are equal, that is m is equal to n. So if the bases are the same, then the exponents must be equal in an equation. Similarly, in an equation, if the exponents are the same, then that means the base must be equal. This is what number 25 is telling you. A raised to m is equal to b raised to m, then that means a is equal to b. Okay, so two things you have to learn in question number 25. One is what they have given. In an algebraic equation, if the exponents are the same, then the bases are equal. In an equation, for example, because it has to be equal, because suppose if you're given a square is equal to b square, this means that a is equal to b. It cannot be otherwise. Similarly, in an algebraic equation, if the bases are the same, then the exponents must be equal. Okay? Then number 27. Any number raised to a negative exponent means it is the reciprocal of that. For example, a raised to minus n is equal to 1 divided by a raised to n. Therefore, 3 raised to minus 2 is nothing but 1 divided by 3 square, which is 1 by 9. Always remember that. Negative exponent means reciprocal. Okay. Now let's do number 30. 29 is similar. We've discussed this before. Like nth root of any number can be written as that number raised to 1 by n. Okay. So this is cube root of 3 whole cube. So cube root of 27 whole cube. So cube root of 27 can be written as 27 raised to 1 by 3, right? Brackets cube, brackets 3. Now 3 and 3 get cancelled, so the answer is 27. Very simple, right? We've discussed this before, but I thought I'll do this again. 31 is also similar. Please do it yourself. Let's do 32. Now, yeah. So this is a new rule. Now, this is square root of 3 into cube root of 729. What is the formula saying? Nth root of m into square root of a can be written as nm. Remove the m from the square root into square root of a. So this can be written as 2 into 3. Nmth. This will be nmth root of a. That is, here we have given square root of 3 into cube root of 729. So we can write this as 2 into 3 root of 729. That is 6th root of 729, which is 3. How did you get 3? You factorize 729. What is 729? 729 is nothing but 3 raised to, what is 729? Let's check. 3 2s are 6, 243, 81. 3 7, 3 is 9, 3, 3. So how many 3s? 1, 2, 3, 4, 5, 6. So 729 is 3 raised to 6. So 6th root of 3 raised to 6 is nothing but 3. Alright, so number 33 to 37 you can try on your own. You can do it because we have discussed the rules and we have also seen similar examples, so you can do it. Let's do number 38. Okay, so this is 256 raised to 0.16 into 16 raised to 0.18. So what do we do? Okay, 256 can be written as 2 raised to the power of 8. How do I know this? You have to first factorize this into its lowest factors. Then try to see whether you can express it as an exponential term. So 256 is nothing but 2 raised to 8. The whole thing raised to 0.16 into 2 raised to 4, which is 16. 16 can be, when you factorize 16, you will see that it is nothing but 2 into 2 into 2 into 2. That is 2 raised to 4 raised to 0.18. Now we know that a raised to m, the whole thing raised to n is nothing but a raised to m into n. We have seen that rule. So multiply 8 into 0.16, I will get 2 raised to 1.28. Similarly here, this will become 2 raised to 0.72. That is 4 into 0.18. Now the bases are the same, so I can add the exponents. So a raised to m into a raised to n can be written as a raised to m plus n, and that's what I've done here. 2 raised to 1.28 plus 0.72, which is nothing but 2 square, which is nothing but 4. Simple. So this is how you solve that problem. Number 41 is similar to this, so I'm not going to do that. You can try that. Let's do number 39. Where are we? This number 39. Yes. So 5 into brackets 8 raised to 1 by 3 plus 27 raised to 1 by 3, the whole cube and the whole thing raised to 1 by 4. Ooh, it looks difficult, huh? It's not. Very simple. Think clearly. Okay, now this term is equal to, you can think of it as a plus b whole cube. What is a? 8 raised to 1 by 3. What is b? 27 raised to 1 by 3. Use a formula for a plus b whole cube, which is nothing but, first brackets, open another brackets, a cube plus b cube plus 3a square into b plus 3a into b square, the whole thing raised to 1 by 4. So when you simplify it further, 3 and 3 here get cancelled, so it becomes 8. This also becomes 27 because 3 and 3 get cancelled. This becomes 3 into 2 square. How do I get 2 square? 8 is nothing but 2 cube. So 2 cube raised to 1 by 3. Again 3 and 3 get cancelled. So it becomes 2 brackets square. So it becomes 3 into 2 square plus this becomes 3. Why? Because 27 is nothing but 3 cube. So 3 cube raised to 1 by 3 is nothing but 3. Right? Same way, this term becomes 3 into 2 into 3 square. The whole thing raised to 1 by 4. When you expand it, you will get this term. Then finally you will get 5 into 125, the whole thing raised to 1 by 4, which is nothing but 5. And that is the answer here. Okay. So I hope you have found this useful. Please learn all the rules and practice, because that is the only way you are going to get better. Please take care of the question, see the brackets clearly, see what they have given, try to understand and then solve the problem. It's possible. Okay, so we'll start a new topic in the next class. Until then, take care and all the best.